Okay, so the Arrhenius definition. Svante Arrhenius first proposed the theory on acids and bases. His theory was that some compounds form electrically charged particles when in solution. His explanation of the properties of acids and bases is called the Arrhenius theory on acids and bases. An Arrhenius acid is a substance that ionizes, because it's molecular, to form hydrogen ions of H+ in water. An acid will increase the potential for hydrogen ions in an aqueous solution. An Arrhenius base, on the other hand, is a substance that dissociates to form hydroxide ions in water. And a base will increase the hydroxide concentration in an aqueous solution. This, though, has been modified. So the original definition of acids and bases proposed by Arrhenius was good, but it has limitations. Some substances that might be predicted to be neutral are actually basic. So, for example, these cases here. So, it has been found that not all bases contain the hydroxide ion as a part of their chemical formula. So, an Arrhenius base modified is a substance that reacts with water to produce hydronium ions in an aqueous solution. So, for example, ammonia, which is a base, and water, goes to form our hydroxide anion and OH. Now, when acids ionize, they produce hydrogen ions. So here's an example. But it has been found using analytical technology like X-ray crystallography that hydronium ions do not exist in isolation. So in an aqueous solution, the hydrogen ion is extremely positive charge, and water molecules themselves are very polar, so it is highly unlikely that hydrogen ions would exist in water without being attracted to the negative poles of the other water molecules. So, this results in the formation of the hydronium ion. So if that is our water, our proton forms a bond here, and it has a positive charge, and it is H3 positive, So, an Arrhenius acid modified is a substance that reacts with water to produce hydronium ions in aqueous solution. So, for example, hydrogen chloride plus water will give us the chloride ion and hydronium, Where if we have H2SO3 plus water gives us HSO3. So as we see there, the other hydrogen is removed and hydronium. Now, the acidic and basic properties of a substance depend on two things: the concentration of the solution and the identity of the acid or base. Now, an acid that ionizes almost 100% in a water is called a strong acid. So for example, here we have hydrogen chloride or HCl, So 100% of the HCl becomes hydronium in the chloride. The concentration of the hydronium is the same as the concentration of the acid it came from. Strong acids are strong electrolytes and react vigorously with metals. So, there are only 6 strong acids, and they are on our periodic table in our data booklet. Now, a weak acid does not ionize 100%, and only a small percentage of the acid forms ions in solution. So, for example, we have this reaction here, So, we use the equilibrium arrow for weak acids, and weak acids are weak electrolytes and react much less vigorously with metals. And we are going to look at strong bases and weak bases on the next video.